Hi everyone, this is Ms. Lloyd here with another video. This is for my Advanced Algebra 2 course. We're looking into radian measures. We've already talked about the unit circle. That's what my unit circle video was for. And this one, they're looking at radian measures. So how to go, like what is a radian? And then how to go from degrees to radians. So to begin with, a radian is a ratio of the arc length. So the part of the circle, one of the curvy parts of the circle, arc, not arch. And we typically use S as a way to denote what arc length is. So arc length S, sometimes my S's look like fives, I'm sorry, to the radius. So typically anything to do with pi is going to be a ratio of some part of a circle to the other. So whenever you're talking about what pi comes from to begin with, it stems from the ratio from the circumference and the diameter. So here we're looking at just a part of the circle, not the entire thing. So just a section. So we're looking at a ratio of the length of the arc, so not the entire circumference, but just a part of the circumference to the radius. And so when we're looking at this, half of a circle, so 180 degrees, is pi radians. And so say we're wanting to change things, so go from radians to degrees or degrees to radians. So 1 degree is going to be equivalent to pi over 180 radians. So that just means that if we're trying to go from degrees to radians, we'll multiply our degrees by pi over 180. I like to think of it as what I have a 180 degree on the bottom, and so the degree on top, the degree on bottom, those will cancel. It's how I remember it myself. And then 1 radian, make that look a little bit more like a 1 maybe. So 1 radian is equal to the flipped version, so 180, that's really crappy, 180 degrees over pi. So when you're trying to go from radian to degrees, you'll multiply 180 over pi. And then typically radians have pi in them, not every time, but sometimes. And so you can cancel out the pi's that way. So that's my reminder of how or why I use the 180 over pi. So when we're looking at the circle itself and we're doing 30 degrees, so we would multiply in order to get this 30 times, I'm trying to go into radians, so pi over 180. And so 30 pi divided by 180, we want to leave the pi there, so we're reducing 30 over 180, and it reduces to pi over 6. Let me centered, pi over 6. So 30 degrees is the same as pi over 6. When it comes to 45 degrees, we do the same situation. So 45 times pi over 180 ends up being pi over 4. So 60 times pi over 180 is going to give us pi over 3. 90 times pi over 180 is going to give us pi over 2. And 120, I always like to think of this as the reference angle for 120 is 60. So I'm 60 degrees or pi over 3 from 180, which means I'm 2 pi over 3. This is when I just start kind of like thinking of it that way, like how far am I from pi? Because we know what we would have pi here for 180. So if I'm a 60-degree reference angle or pi over 3 from 180, then I'm taking an entire 3 pi over 3, subtracting pi over 3 to get 2 pi over 3. We want to think of it that way. That is helpful for me. May not be helpful for every person. So 135 degrees, we're looking at 3 pi over 4. And 155 pi over 6. So again, 135, 45 degrees is a reference angle. So 4 over 4, take away 1 would be 3 over 4, so 3 pi over 4. So that's just kind of how I remember it. In this next bit, we're just doing the practice. So expressing 135 degrees in radians. So this we already did. So 3 pi over 4. Easy peasy lemon squeezy. The next one, this is in radians. It has the pi, and they want us to put it into degrees. So I have 4 pi over 5. So I'm going to do the reciprocal of what I was doing before since I'm trying to get to the other side. So I'm going to be multiplying instead by 180 over pi. So 180 degrees. So notice here my pi's will cancel out. And so I'm doing 4 times 180 divided by 5. And so this ends up giving me 144 degrees. So whenever you're changing from radians to degrees, the pi should cancel out, or it could be you don't have pi at all, because you couldn't have just, what, here they say 3 radians. So it doesn't necessarily have to have the pi in it. All right, so this next one, we're expressing 34 degrees in radians to the nearest half of a radian. So here they're giving us a hint that we're going to be using decimals. So I've got 34 degrees, and I'm changing it to radians, so I know I want my 180 on the bottom. It would cancel out my degrees. Pi on top. So the little degrees are gone. So I would have 34 pi over 180. And when I plug this into my calculator, so I'm using the pi button, this ends up being 0.59 radians. And we do want to be specific and say radians. So if you just put 0.59, it's like, okay, what is it? Is it 0.59 tacos? Because if it is, who ate part of the taco? Why would they just leave it? Everyone's going to eat a full taco. No one wants to eat part of a taco and just leave the rest of it. All right, so next one we have 3 radians, and we're changing it to degrees. So I have 3. If I'm trying to change 2 degrees, that means I have my pi on the bottom, 180 degrees on top. So multiplying through, I have 540 over pi. And again, I'm going to hit my pi button. And we get about 171.97 degrees. And we're done with that. So here, these are just more examples going from degrees to radians. And so here first they are asking us to put it into terms of pi and then put it in as a nearest 100th of a radian. So you can go ahead and pause the video here, check it out yourself, see how you do. You're going to see a magical, suddenly all the answers are here, like bippity boppity boo. And here are the answers. So moving from 255 degrees, we would have 17 pi over 12, which is approximately 4.45 radians. For 330 degrees, we'd have 11 pi over 6, which is approximately 5.76 radians. And then for negative 405, we have negative 9 pi over 4, which is approximately negative 7.07 radians. And then we're ready to go in the other direction. So then here, we're going from radians to degrees. And so these first two, we should be able to do because I kind of showed us earlier. And then the second two, they don't have pi, and so that can be a little disorienting. So I'll show you that in a little bit, more individualized steps. All right, so for 2 pi over 9, we've got 40 degrees. And 8 pi over 5, we have 288. So for this next bit, we're still using the same method. So I have my 5 radians, and I'm still multiplying that by 180 over pi. So I'm going from radians to degrees. And so multiplying across the top, we can say that's like over 1. So I've got 900 over pi. And then plugging that in, because it does say, if necessary, round your answer to the nearest tenth of a degree. So I know that means I'm going to be plugging it in. So plugging that in, we end up with about 286.6 degrees. And then next one, so we're doing the same thing for negative 1.4. You can pause the video if you like and try it out yourself. See how well you do. But again, going from radians to degrees, so degrees is on top, pi is on the bottom. And then plugging that into our calculator, what we end up with negative 252 over pi, which then will give us approximately negative 80.3 degrees. So, and that's depending on what pi you use and how you round. So if that last decimal is off, it's not life or death in this situation. So very last question that I'm going to go over with you. If we have an arc length of a circle, so part of an arc, that's 2 radians. So I don't know off the top of my head what exactly 2 radians looks like. So I'm just going to draw a visual, not at all exact or to scale representation. So I'm going to say, okay, here's 2 radians. So we're talking about, again, the angle. So our angle is 2 radians. And then the radius is 3. So we're talking about this line here that goes from the center and out. Again, probably not to scale. And they want us to find the length of the intercepted arc. So they're wanting us to find like the crust of the pizza, if you will. And then after we find the crust of the pizza, they want us to find the area of the related sectors. So they want us to find the area of the slice. So how big is the slice of pizza? And so here, in order to do that, we need a few other formulas. And so I have that written down, keeping in mind that anytime we have a theta, theta represents the angle, but that angle has to be in radian measures. It doesn't work if we try to use degrees. So these are the different formulas that we will use. So in order to find first the length of the arc, so this is where that s came in from before. So I'm trying to solve for s. So there is equal to my radius. So in this case, we have 3 times the angle in radians, so 2. So my arc length here, nice and pretty number, is going to be 6. And then I'm also looking for the area of the sector, so area, and I can make that in blue so it matches, is equal to 1/2. Again, they want my radius, so 3, and then we can plug in, I'm going to use the bottom formula because it just seems a little bit quicker. So S, the arc length, so we have 6. And so 3 times the 6 would give us 18. Half of that, our area is going to be equal to 9. And then we're done. They don't give us the measurement of the radius. It's just a 3, so it's just units. And so this is as far as I'm going to take you on this mathematical journey. I hope you had a entertaining time. My students can find their homework on the LMS page, which specific problems you're going to look at. If you're not one of my students, you don't have to do the homework, but you can leave a comment below if you have any questions. So, mathly yours, Miss Lloyd.